So, we are on sound wave chapter, and currently we are talking about the types of vibration, and one of them is resonance. So, resonance is a special type of force vibration. Okay, before that let me give you few examples of resonance, or ये क्या होता है basically, and how many types of vibration are there. So, in that video I am going to give information about resonance, force vibration, free vibration, damp vibration, and few questions from board paper I have discussed in this video. So, let's begin this lecture. So, during the lecture I showed you my guitar and I gave you the basic information about the working of guitar. So, basically guitar works on the principle of resonance. So, what is resonance actually, and how many types of vibration are there? Basically there are 4 types we have seen so far. ठीक है, सबसे पहला तो हमने फ्री वाइब्रेशन देखा है, फ्री वाइब्रेशन और नेचुरल वाइब्रेशन. Now, free vibration is possible only in vacuum. Okay, oscillating pendulum, vibrating tuning fork, vibrating string, they all perform damped vibration. Second number, damped vibration. Now, what is the meaning of damped vibration? Damped vibration में क्या होता है basically, because of external resistive force. In case of vibrating string, यहाँ पे जो contact है, because of that there is friction. Also air is there, so due to that the string will stop vibrating after some time. In case of simple pendulum, if the pendulum is vibrating in air, after some time it will stop vibrating because of external air resistance. So, because of the external resistive force, the body will stop vibrating. So, we call it damped vibration. ठीक है, damped vibration. So, and the third case is force vibration. Force vibration. If I want to make this pendulum to continue its oscillation, अगर इसको continuously oscillate कराना है, so we need to push it time to time continuously, so that its oscillation will sustain. In that case we call it force vibration. तो force vibration में क्या होता है, you need to apply external force to make body vibrate. We call it force vibration. Let me give you one example of force vibration. So this is the example of force vibration. Okay, the child is swinging. Okay, and we know that in this case we have to constantly push the swing so that it will continue oscillating for a long time. Okay, so external force supplies energy to the system. Such motion is called force vibration. If we do not apply force, so the swing or a pendulum will vibrate or oscillate, and after some time it will come to rest. Okay. But if you constantly push it, if you constantly apply external force, it will continue oscillating. So, we call it force oscillation or force vibration. Now, fourth type is resonance, and resonance is a special one. So, let us talk more about resonance. So, resonance is a special case of force vibration in which two bodies, okay, they oscillate with the maximum amplitude and in phase. Okay, they perform the vibration of the same frequency. They will perform the oscillation of the same frequency and with the maximum amplitude, but for that purpose their natural frequency has to be equal. So, for example, I am having two pendulums, okay, and they both are having same length, and let me take one more pendulum. They all are connected with the string. Let me draw one more pendulum which is longer than these two pendulums A, B, C, A, B, and C1 is having larger length. So, its a natural frequency will be different. So, if I displace this pendulum, if I disturb this pendulum, it will oscillate, okay, and its energy will get transferred to the B and pendulum C. So, you know what, A and B, they will oscillate with the same amplitude in phase, same amplitude, same maximum amplitude. So, they will perform resonance. Okay. So, this is the driving pendulum, it will produce the driving force because I am pushing this pendulum first. So, it will oscillate, its energy will get transferred to the B and C. B will also oscillate with the same amplitude because their natural frequency is equal. So, they will perform resonance. Okay. It means B will also oscillate with the same amplitude. Now, what about C? C will perform force vibration. Now, this is also an example of force vibration resonance, but in case of resonance, both the bodies will oscillate with the same maximum amplitude. Okay. In this case, amplitude may be different, but it will not be equal to A and B. Okay. So, C will perform force vibration. Why? Because its natural frequency is different, because its length is different, and we know that in case of simple pendulum, uh, this is the formula for natural frequency, L, sorry, L. So, if the length is different, frequency will be different. So, here in case of this pendulum, its natural frequency will be different. Only these two will have equal natural frequency. So, these two will perform resonance. So, they will perform oscillation with a maximum amplitude. Amplitude reaches maximum at resonance. Energy of the system becomes maximum at the resonance. So, maximum energy will get transferred between these two pendulum, and less energy will get transferred with pendulum C. Okay. So, one more example they have shown here. There are the two vibrating, there are the two sound box. Okay, they are having tuning fork on the top of that. So, if you strike this tuning fork, it will vibrate, and it will cause sound, air inside to vibrate, and that vibration will get transferred to this system, and due to the resonance, this tuning fork will also start to vibrate. But there is a condition: if the frequency of this tuning fork is 256 hertz, the tuning fork B should also have same frequency, so that resonance will occur. So, one condition is there, frequency has to be equal. Okay. Frequency has to be equal. External driving force and that of body, the frequency of these two has to be equal, then only resonance will occur. Now, let us see a few examples of resonance. Now, this question was asked in 2019 board exam. Okay. It is related to oscillating pendulums. As you can see here, C and D, their lengths are different, so their natural frequency will be different. It means if you oscillate pendulum C, energy will get transferred to the pendulum D. It will also vibrate, but it will perform force vibration. It will not perform resonance. Why? Because the lengths are different. There will be transfer of energy, but transfer of energy will be less. There will be no resonance. So, let us check this question. Two pendulums C and D are suspended from a wire shown in the figure. Pendulum C is made to oscillate. इसको हमने disturb किया. Okay, pendulum C is made to oscillate by displacing it from the mean position. Obviously, it is seen that D also start oscillating. So, obviously, energy will get transferred to the pendulum D. It will also start to oscillate. Now, name the type of oscillation C will execute. So, it will perform force vibration, force oscillation or force vibration. ऑसिलेशन है बेसिकली, वाइब्रेशन हम स्ट्रिंग के केस में यूज करते हैं. यहाँ पे आ जाएगा ऑसिलेशन, फोर्स ऑसिलेशन. ठीक है. नाउ फर्दर, ओके, डी विल परफॉर्म फोर्स वाइब्रेशन. सी, ये कौन सा, डी विल परफॉर्म फोर्स वाइब्रेशन. सी कौन सा परफॉर्म करेगा? सो सी विल परफॉर्म डैम्प्ड वाइब्रेशन. डैम्प्ड वाइब्रेशन, ऑसिलेशन, ऑसिलेशन है ना, क्योंकि आफ्टर सम टाइम after some time due to the air resistance its oscillation will come to rest. So, it is performing damp oscillation. You can also write natural oscillation or free vibration or natural vibration, but all the vibration here on earth in the presence of air are damped vibration or damped oscillation. So, C will perform damped oscillation. Now, further, if the length of D is made equal to C, then what difference will you notice in the oscillation of D if both the length are equal? The length of C and the length of D is equal, then what will happen? Obviously, the energy will get transferred to the D and resonance will occur, because they both are having same natural frequency is equal. So, driving pendulum and oscillating pendulum, they both are having same natural frequency, because their length is equal now. Okay, so if we make the length equal, D will oscillate with the maximum amplitude. ये word यहाँ पे key word है, maximum amplitude. ठीक है, so it will oscillate with the maximum amplitude. Okay, and this phenomena is known as resonance. So, these type of question they ask in exam, basic concept based है. Basically there are 4 type of vibration: free vibration, force vibration, damp vibration and resonance vibration or oscillation. So, you need to remember all these types of vibration. Now, let's check this one. ये टेक्स्ट बुक का क्वेश्चन है बेसिकली. इसमें चेक करते कि कौन से पेंडुलम का लेंथ इक्वल है. सो एज यू कैन सी हियर A and D, they both are having equal length, means there will be a resonance between A and D. What about B and C? B and C will also vibrate, but since their length is different, their natural frequency will be different as compared to A. So, they will perform forced vibration. So, forced oscillation or vibration. ठीक है, force oscillation or vibration और resonance. ये दो ही केस बनता है ऑसिलेटिंग पेंडुलम के केस में, रेजोनेंस ऑसिलेशन. ठीक है, अब देखो इसको रीड करते हैं. फर्दर क्या मेंशन किया, ए इज इनटू वाइब्रेशन. ए को हमने पुश किया, ए इज वाइब्रेटिंग, इट्स एनर्जी विल गेट ट्रांसफर टू ऑल द पेंडुलम्स, बट ओनली सी विल वाइब्रेट विद द सेम एम्पलीट्यूड एज दैट ऑफ ए, because they both will sorry D वाला लेंथ D का इक्वल है ना, सॉरी D वाला, not C वाला but D वाला, my bad. D, because their length is equal, so they will have resonance, they will have resonance and they will execute the oscillation with the same amplitude, same maximum amplitude. ठीक है. So, what is your observation about the vibration of pendulum D? So, D will oscillate with the maximum amplitude. ये वर्ड आना चाहिए यहाँ पे, maximum amplitude, and it will perform resonance. Wow, what is the reason actually? Give reason. Because the natural frequency of D is equal to frequency of pendulum A, which is driving force, frequency of pendulum A. ठीक है. So, ये driving force है because A was oscillating initially. तो इसका जो फ्रिक्वेंसी है D के इक्वल है, दैट्स वाई मैक्सिमम एनर्जी ट्रांसफर विल टेक प्लेस एंड D विल आल्सो वाइब्रेट विद द मैक्सिमम एम्पलीट्यूड. नाउ फर्दर, व्हाट टाइप ऑफ वाइब्रेशन टेक्स प्लेस इन B and C? सो दे विल परफॉर्म फोर्स वाइब्रेशन और फोर्स ऑसिलेशन. ठीक है. सो व्हाट इज द रीजन? बिकॉज देयर लेंथ्स आर डिफरेंट, the natural frequency is different as compared to that of A, and hence they will perform force vibration. Give reason, because length is different, natural frequency is different as compared to that of A. Okay, so they will perform force vibration. Now this is related to pendulum. एक और क्वेश्चन है यहाँ पे. अब देखो ये जो क्वेश्चन है ना, ये 2017 बोर्ड एग्ज़ाम में पूछा गया है. ठीक है, अब इसमें क्या बोला है देखो, और ये ना सोनोमीटर है. बेसिकली सोनोमीटर का कॉन्सेप्ट क्लास 12th में भी है. इन क्लास 12th विल लर्न इन डिटेल अबाउट सोनोमीटर. सो सोनोमीटर बेसिकली क्या होता है, ये जो डिवाइस है इसमें एक हॉलो बॉक्स होता है, ऊपर दो नाइफ एज होते हैं और उसके ऊपर से एक स्ट्रिंग पास होता है, एंड देर इज़ सम वेट सस्पेंडेड थ्रू द स्ट्रिंग सो दैट it will create tension in the string. So let me show you the picture of sonometer. ये रहा सोनोमीटर का पिक्चर. ठीक है, ये सोनोमीटर बॉक्स है. इट्स अ हॉलो बॉक्स, just like in guitar there is a sound box. As you can see, there are two knife edges and there are two strings they have used. ठीक है, ये स्ट्रिंग के ऊपर ना पेपर राइडर ऐसे रखते हैं और एक वाइब्रेटिंग ट्यूनिंग फोक इसके ऊपर नाइफ एज पे रखते हैं. सो व्हेन ट्यूनिंग फोक वाइब्रेट्स, the vibration will get transferred to the vibrating string, and when the resonance occurs, the frequency of vibration of tuning fork becomes equal to the frequency of vibration of vibrating string. It will vibrate with the maximum amplitude and the paper rider will fall. Paper rider will fall, and paper rider will fall only when resonance occurs, because at resonance the string will vibrate with the maximum amplitude. ठीक है, between the two knife edges, and the paper rider will fall off. So related to this there was a question. Yeah, check this one. Diagram above shows a wire stretched over a sonometer, stem of two vibrating tuning fork A and B. There are two tuning forks touched to the wooden box. Okay, they kept the tuning fork over here. Either you keep on the top of this knife edge or you keep on the top of the sonometer box. The vibration will get transferred to the sonometer and eventually it will get transferred to the string. String will vibrate, and when the resonance occurs it will vibrate with the maximum amplitude. Okay, and the paper rider will fall off. It is observed that the paper rider, a small piece of paper folded at the center, present on the wire, flies off when the stem of vibrating tuning fork B is touched on the wooden box. But the paper rider just vibrates when the stem of vibrating tuning fork A is touched on the wooden box. So basically क्या करना है, पहले ये वाइब्रेटिंग ट्यूनिंग फोक उन्होंने सोनोमीटर बॉक्स पे रखा ए वाला, तो पेपर राइडर जस्ट वाइब्रेट हुआ. जस्ट वाइब्रेट मीन्स इट्स अ केस ऑफ फोर्स वाइब्रेशन, नो रेजोनेंस अकर्ड. देन दे केप्ट ट्यूनिंग फोक बी ऑन दिस सोनोमीटर and paper rider flies off. Paper rider fell because there was a resonance. The resonance occurred. इसका मतलब क्या हो गया कि ट्यूनिंग फोक का जो फ्रिक्वेंसी है एंड स्ट्रिंग का जो नेचुरल फ्रिक्वेंसी है, दे बोथ आर इक्वल. देन ओनली रेजोनेंस अकर्ड and the paper rider fell because the string vibrate with the maximum amplitude. ठीक है, तो ये देखो यहाँ पे देखते हैं, रीड करते हैं. नेम द फिनोमेना व्हेन द पेपर राइडर जस्ट वाइब्रेट. तो ये तो फोर्स वाइब्रेशन हो गया, फोर्स वाइब्रेशन. बहुत ही लंबा क्वेश्चन है लेकिन इजी आंसर्स है. ठीक है, देखो ये स्टेटमेंट बहुत लंबा है लेकिन क्वेश्चन इजी है. नेम द फिनोमेना व्हेन द पेपर राइडर फ्लाइज ऑफ. रेजोनेंस. Resonance, because the string will vibrate with the maximum amplitude and the paper rider will fall off. Why does paper rider flies off when the stem of tuning fork B is touched on the box? So resonance occurred and string will vibrate with the maximum amplitude, string will vibrate with maximum amplitude. Maximum amplitude is a keyword here, and due to that the paper rider fell off. Okay, so this is another example of resonance. Okay, in class 12 you will learn a lot about sonometer and that vibrating pendulums and resonance tube.